All right. I'm going to
Oh,
record.
recorded now.
Okay. So Levi number 1, we'll call you Minecraft Master. And then Levi number 2 will just be Levi.
Miss Tara,
Are you master
Levi.
first?
Yeah. Yes, Miles.
Miss Tara, can you call me Miles 783-231-0998?
I can. If there's another Miles that joins the class, maybe. All right, let's see. Let's share my screen. It is virus day today. All right, can everybody see my lovely picture of a virus?
Yes. Yeah.
That's computer
Looks like it
generated.
has raspberries on it.
All right.
Kind of does.
Sorry, I'm still getting over my virus, which we will be talking about today. It's story day. Now, I will say we'll have a Kahoot at the end. So today's going to kind of be like a university lecture class where you're going to write down some key notes. There's a big number on this page. But
What kind of note?
10,000 billion billion billion.
Yeah,
And our notes going to be in blue. Major notes are they going to be in blue?
I'm not telling. But a lot of the slides, you want to write down important notes, right? This is great note-taking practice because at the end, there's going to be a Kahoot quiz, okay? And they're most likely going to be on these slides. So
I'm trying to write down all the zeros.
I've never done a Kahoot before, so I'm excited.
well, I did write, oh, good. I did write the 10,000 billion billion billion. So it's actually 10 to the 31. And that's how many viruses are on Earth.
When you say that, do you mean that's how many like are on or how many are known?
How many are actually on Earth?
Okay.
Not species. How many viruses are on Earth?
But how many species of viruses? A virus are there?
That's a great question. I know how many. We'll actually see here in a second how many we care about. And in fact, there's so many viruses that in the ocean alone, 40% of bacteria are killed by them. Poor bacteria. Don't we feel so sorry for them?
So
If it's the bad
40% of the
bacteria.
bacteria is killed by the ocean?
40% of bacteria in the ocean. Hey, Miles, can you not draw on the board today? Thanks, sir.
I was just typing a big number.
I love it. That
Okay,
was a
fine.
gigantic number. Okay, so
So
yes,
small.
40% of the bacteria are killed by viruses. And in fact, 8% of your DNA in your body now is viral DNA. And yeah, so we'll learn about that next class when we talk about the vaccines and cures and antibodies, right? But basically, it's like a memory of past viruses, right? That your body has inside of it. So inside the cells, and its DNA is part of viruses, viral DNA. Okay. So your ancestors live on through your genome. You know, if they got a virus, it's actually replicated in you. Pretty cool. And so my question to everyone. So how do viruses become so successful? I mean, let's talk about it. They don't have memory. They don't really react to anything. They can't multiply on their own. They can't actively do anything. And they just stumble upon victims by chance. So how are they surviving?
Randomly.
Because there's a lot of them out there, maybe.
Okay.
There's just so many, but there's just so many that the chance of them stumbling upon somebody is almost 100%.
It's a high chance.
They're
Of
really
infecting.
high chance.
All right. So essentially, viruses are only good, when they can act, when they can only be damaging. I shouldn't say good. They can only be damaging when they actually reach a living cell, right? And this is the fun thing about viruses is they can only attach to matching receptors. So you kind of have to think of it like a puzzle piece. Certain viruses have receptors on the ends of them, and we'll see there different ones in a second here, that can then attach to your cells receptors. And it's sort of like a puzzle. Some of them fit, some of them don't fit on certain cells. All right. So let's talk about the anatomy of a virus. So what do we have? You guys explain the anatomy of a virus. What we have so far. Who can name some things?
There's proteins.
All right. So we hear that a lot. We call them like COVID, right? Or influenza. We have spike proteins, and that's what's going to attach to the receptor cells. All right.
The gland.
Capsid, which is like the capsule or the shell of the virus.
That's right. It's made of protein. So it's not really it's the shell, but it's the shell of the DNA. So it's kind of in there, right? All right. What else we got?
Then
Do you know
the shell. If the capsid is the shell of the DNA, then the envelope is technically the capsule of the entire virus.
Right. So it's made of, the envelope's made of the lipid. Let's see if I can show you guys my virus thing here, this outside piece here, right? That's the lipid, which is very much like soap lipid, which is why you use soap to kind of wash it away. The like dissolves like premise. So that's your fat. Lipid's another name for fat. Encapsulation, right? Capsulate I guess you call it the envelope, right? Is one. What's another part of your cell, I'm sorry, not your cell, the virus?
The matrix.
Oh, the matrix. That sounds super cool.
The
They made
movement.
a whole movie
That.
about it.
So that is extra protein under the envelope. So it's kind of like an extra layer of protection. Okay.
I'm seeing a lot of defense on this virus.
Yeah. Here, let's see if I can show you.
Virus a virus.
If you have this, you guys still have this virus morphology sheet that we did last time?
I
If you
do.
don't have it with you, that's fine. But this is part of it. So if you have it with you, we have the capsid, genome. What's genome?
Like the RNA and DNA.
Yeah, it's how it's going to replicate, right? It's the instructions on what it's going to give our cells to replicate another virus. All right. Then we have the envelope. They do have some proteins. Now, 3 through 6 here is not all viruses. So definitely all viruses have a capsid and a genome. And then 3 through 6, the envelope, proteins, matrix, glycoproteins, those are your spike proteins. Those are kind of different depending on your virus. Okay.
What virus doesn't have a spike protein? Because they can't attach without it.
So we'll go over the different types of viruses for sure. I don't know if this time, if we have time this time, we will, but next time we definitely will. Okay, so our story is going to begin. And I chose influenza because that is what I am getting over. It feels like everyone on the Newfoundland Island has influenza right now. So that's what I'm focusing on. So here, Desiree, is your answer to your question on how many species. So the ones we care about, there's 200 species of viruses to infect humans. So compared to how many viruses are on Earth in general, that's not too bad, right?
Yeah. I was thinking like somewhere around 1,000 in total, like the overall amount of viruses on Earth.
Oh, you have to look it up. I don't know the number for that. If you can look it
I
up and
can't
let us
look it
know.
up.
Yeah, look it up and let us know. All right.
That's my mom's look.
There you go. Viruses are specialists, not generalists. So what does that mean? that means they only attach in special ways to certain cells with the exact same receptors. Okay.
I got
So-
a question.
Yes.
What's below influence? I can't read that.
Oh, sorry. That's Italian. Okay. So influenza is a word, came from an Italian word for influence. And it was back in like the Middle Ages. And this is a time when people thought the stars and the planets influenced our behaviors, or if you got sick or what's going on, right? So it's kind of like Middle Age thinking. But
Fun.
this word evolved to influenza. And that's where we get.
That's it down.
And of course, nowadays we just shorten it to the flu, right? So we don't generally say influenza. We say, oh, I have the flu. All right. So this guy is in your, let's say, classroom, playground. Where do you want the setting of your story to begin?
A mall.
Garbage.
The mall.
front of
Yes,
you.
there are lots of sick people at the mall.
Okay, the mall. Okay, so you guys are out shopping or going to the arcade or doing something, right? And this guy comes up to you guys and just sneezes everywhere. Okay.
You indecent life form.
That's right. He's not very nice, right? Okay, so what's
he-
happening? So somebody tell me what happens. He is infected with influenza. So how are you getting it?
From the
So-
air.
It's
Well,
like you
I
walk
mean-
into it and the clump in the air.
Well,
It's the, it's
You breathe it in.
Well,
did-
it's attached
well,
to the
didn't-
water droplets.
Didn't we say that
That's the
virus
key.
needs liquid to
Right.
attach?
exactly. You
Miss
cannot
Kara,
breathe in influenza, right? That's not what you're doing. You're not wearing, like when we had to wear masks, you're not wearing a mask because influenza is just floating around, right? The viruses is just,
Miss Kara,
Desiree had it
They
right.
need
It's actually encapsulated in aerosol. It has to be in a mucus or a water encapsulation, right?
So then once the mucus gets on our face, let's say that'd be gross, but let's say it gets on our face.
Right.
Then probably.
That's right. So the virus is super, super small, but the water droplet or the mucus is very, very large. So that you're trying to prevent the mucus from getting to you, okay? Or the water aerosol droplets, right? From spreading. Well, unfortunately, it does. It gets to you.
Miss
So
Kara,
the good thing, yes, Miles.
sorry for interrupting, but I couldn't help noticing that the background is from an app made by this guy called Courage Zagat or something.
Okay. Didn't know
I
that.
was I have an app like that.
That's pretty cool. Well, you'll see a lot of pictures like this made by him then. Okay, so the water droplet has gotten on your face. Do you care? Do you care if it touches your cheek?
Yes.
Yes.
No.
Whoa.
I mean, it's gross, but what's on your skin? What's the first layer on your skin? Is it living cells?
The-
Dermis.
That's right, but are
Dead
they living?
cells. Dead cells.
There's a huge layer of dead cells on your skin. That is your first, like your living cells are layers down, a lot of layers deep. Okay. So we don't really care if it touches our hands or whatever. I mean, what we care about is if our hands then go in our mouth, right? Okay. So it's fine that it touches your skin because it's dead cells, and viruses don't care about dead cells, right? So unfortunately, some got in your mouth, right? And you're breathing something in. So this is where our lovely infection begins. All right. So how are we preventing the virus from getting to our cells? How is our body
we,
preventing them?
we drink hand sanitizer.
Whoa.
Okay, you don't have
Whoa.
so you don't have hand sanitizer, so you don't have alcohol to dissolve the water, right? Or the lipid.
we have
don't have that. So we're
nice
done with
immune
all that.
system.
It is now you're breathing it in. So what is our first line of defense in our body?
White blood cells.
Oh yeah.
Okay, we got white blood cells.
We got the mucus or something. Mucus must be something.
Okay, so we care about this because in general, we have how many cells in our body?
A
A
lot.
lot.
4 trillion?
40 trillion.
Trillion?
Each one of those dots is 10 billion cells. Okay, so we have 40 trillion cells. So we have a lot of cells to protect, and the virus can get to a lot of those. Okay, so we want to try to protect those. So our first line of defense is going to be, let's say we breathing in what that guy just like sneezed out, right? So we have nose hair, right? Our nose hair catches some of it, right? This is like your boogers and all that kind of mucusy stuff in there. It's all protecting you, right? And then we have mucus in our throat, right? We're coughing some, we're trying to, our mucus lining is now getting, so a bunch of the virus that's encapsulated in mucus itself and water is getting out. So that's awesome, right? But where our story is going to continue is we have one lone virus that made it. So very unfortunate.
Just one.
What are
We
the
got
what are
one
the
die.
chances
One,
of thousands of viruses one makes
out
it?
of all of them.
one is going to
Oh,
make
if you see a second version of us, it's just because before the computer froze and our internet dropped. So I'm trying to have an extra one open just in case.
okay, that's fine. Okay.
Miss Tara,
Yes.
why do viruses even exist?
Ooh, that's
Because Mother Nature.
sort of, yeah. I mean, they are thought to have transmutated from cells and stuff. Like that's a new discussion, but yes. All right. So in general, can we stop breathing?
No.
No.
No, we
Not
can't.
Not for very
really.
long.
How much do we inhale? How much air do we inhale a day?
Apparently a couple thousand
Thousands.
pounds.
A lot.
Yeah, a lot.
Probably
All right. So in general, our lungs, so Levi, like you said, there's mucus layer all throughout our our lungs, I guess, or our respiratory system, I should say. There's about 145 square yards of surface area of our lungs. Okay. Now, if you don't know how much that is, it's 60 times the surface area of your skin. Okay. That's how much surface area is just for your lungs. All right. So they have a lot, that one virus has a lot of surface area to cover. So we have a nice mucus lining. Now, we can't line. Oops. Can you guys see me?
Yeah, we can see you.
Yeah.
Hold on. I lost you guys. Hold on. Give me back Zoom. Okay. Am I still on share screen for you guys? Probably not. Okay.
No.
See that happen.
No.
Okay. Coming back. Can you see it now?
Yeah.
Yes.
Okay.
Yeah.
Perfect. All right. So we have a lot of surface area. We can't line everything with mucus. Why is that? What's in our lungs that we
Because-
can't line with mucus?
Macrophage.
Nope.
That looks like a chicken leg.
Isn't it
Very,
like
very bottom.
it looks sounds like broccoli.
Yes, it does look like a broccoli. Who's taken
It
a
sounds like
that knows what those things are?
Avioli.
sounds like
Yeah.
broccoli.
Yes.
It literally sounds like
It
broccoli.
sounds like broccoli. That's what I said.
These sacs are your air sacs. This is how you're breathing. So these cannot be filled with mucus, right? We wouldn't be able to breathe. So this is our air sacs. This is how we're breathing. So in order to stay safe, our next line of defense is going to be, actually, there's our mucus and our antibodies and our white blood cells, what Grace was saying. But our next line of defense is who remembers this word from English origins class?
Micro.
Oh, me.
Phage.
Yeah, what does that mean? Who remembers what phage means?
Phosphorus.
Remember, it's a
Flash eater. I remember flash eater. No,
macro is large and phage is eater, so it's a large eater.
That's right, it's a big eater. So these things, you can kind of see it at the bottom of the page there. These things' sole purpose is to kind of go around, if it sees a virus, is going to eat it up, dismantle it, and spit it out body parts, right? That's its job, this microphage. So it's kind of it's just patrolling around and seeing what's different viruses and bacteria. I think the one at the bottom it's eating bacteria, but everything around this is going to be our line of defense. Instead of mucus, the macrophages are going to kind of clean up things around there. Okay. All right. Now, in our body, when we say skin, we think of the outside. When we think of the skin on the inside, what kind of cells are on the inside?
Yeah.
That's blood cells.
Say that again.
Blood cells.
They're right here at can you read this
Oh.
word?
Epithelial cells.
There you go. That is the epithelial cells are the inside skin. So the inside of your body, like if you were to take your skin and turn it inside out.
Ew.
Yeah, kind of ew. But these would be our skin. So these are everywhere. These are our epithelial cells. All right. So once a virus can hook to these by certain receptors, right? It can then take over. That's where it transfers its genetic material to its victim, right? And the victim is unfortunately our cells. Okay. Now we can scan for flags. When we were learning about the cell last time, we learned that there's some proteins that have flags like, hey, hello, macrophage, there's a virus here, right? But unfortunately, this one virus has gotten into one of our cells. Okay. So that's very unfortunate, but it happens all the time. Okay. So once it gets in, what happens, guys?
Who should this is?
It releases its genetic material into the
cell, and it reproduces.
cell.
and then it replicates the virus itself.
All right. So we got sneezed on in the mall, and it took the virus 1 hour to beat all of our mucus and antibodies and everything and come down all the way to our cells. And it took, once they met one of our epithelial cells, it took 10 minutes to trick that cell in delivering genetic material. Okay. Inside of that cell are antivirus proteins. And guess what? The virus also made antivirus attack proteins. Or sorry, not antivirus, just attack proteins to kill the antivirus proteins. So
Antivirus protein.
that's right. Attack protein. So the cell is a kaput, right? This is no good. This is no bueno for us, right? We now have a cell that is just replicating a virus. That's its only job, is to just crank out viruses. Who's ever heard of the Trojan horse story?
I've heard of it.
Okay, can somebody kind of give me the gist of it? Like the rundown of what happened?
The Trojans, after the Greeks fled, the
Built
Trojans
a wooden horse. They knocked on Troy's door and they say, "Hey, we've got a package for you," and they let it in. And they all came out of the horse and killed everybody.
Okay, so
yeah.
your body is the city of Troy. Okay. And the virus is in the soldiers inside of that horse. That horse is your cell. Okay. So
I
each,
may never pick up an Amazon box again.
each one of your cells is sort of like a Trojan horse because you don't know which one the virus is hiding in. And none of your immune system knows which one the virus is hiding in. Okay.
That could be made into a game.
That could be made into a game. This only happened, like it only happened once it starts making the cell starts then replicating the virus and makes thousands of new viruses. Does the cell then kind of burst open and let them all out? And now you have thousands instead of just one virus. Now you have thousands infecting all of your cells. Okay.
What's
So-
the black and white photo?
That's an actual picture of one. So nothing mutates faster than a virus. Nothing. Here's actually influenza, since I'm still recovering. So let's think of it this way. If you have one influenza virus, okay, that went into your body, which is highly unlikely, you probably have a lot. But let's say we just have one. That one will infect 22 new cells every hour. Okay.
Wow.
So the cell will then die of exhaustion because it's just all it's doing is it's a factory for viruses, and the cell will die, and then you'll have thousands more viruses. So within a half a day, if you could, do a 22 factorial there with your exclamation point, all our math people, if you could do a half a day and do 5 cycles of these 22 times, one virus within half of the day will have infected 5 million of your cells.
One virus.
One virus.
Well, that's
Wow.
without your immune system, of course.
Yeah. So the immune system has not kicked in yet. We're not there yet in our story. The immune system has no idea that this virus is here yet. This is in a half a day. They've sneezed on you, right? And one has gotten in. So we don't feel a thing, right? We're just walking around the mall like nothing's wrong. Okay. And this is what's going on in your body. So we hear a lot of viral load talk, like especially during COVID. Another reason why they wanted you to wear a mask is one virus getting in is way better than like even 2, right? So it is.
2 would be 10 million cells.
It would be exponential, right? So this is very, very serious. You only want a little teeny. If you have to have a virus in, you only want a little amount. Okay.
Miss Tara,
Yes.
sorry for interrupting. So if you were to get infected by one virus and you didn't take any medicine whatsoever, how long would you survive before you died?
Okay, so we're about to talk about that. That's part of our story. All right, our first defense is cytokines. All right, now these are awesome little proteins in your body, and their job is to slow down the production, because you got to think, what are you guys going to do? What should we do? I mean, this virus is just unstoppable, right? How are we?
Kill 5 million cells.
So how are we going to stop it? Well, the first thing to do is the release of these things. Like there is a hint that something is wrong. Okay. The first hint in your body that something is wrong, your cells will go, wait a second, something doesn't look right. Where our cells are dying and this stuff is coming out that does not look like us. So they send out cytokines. All right. Now, one type of cytokine is called interferon. Okay. And what that does is it ignites your immune system. So here we go, Levi. Here's the first part of your immune system starting. And it says, it just sends out warnings to all of your cells. Stop your DNA, your production of proteins. Stop all of it. Stop making RNA, the messenger RNA, stop making it, because we don't know if it's a virus or not. So that lessens the severity of the amount of viruses being replicated, right? If all your cells stop production, the factory is shutting down, right? So that's our first line of defense, like halt all production until we figure out what's going on. So that's cytokine interferon. Does everyone write that down?
What?
Cytokine, and that was a interferon cytokine. So this is our cell, this is our cytokine
How
that
do you spell that?
it's on the screen. Can you see it? This is the one that's going to slow down the production of a virus.
Oh.
And sometimes it signals other cells to kind of destroy themselves if they see something in there, but it's definitely going to activate. This is our first line of defense. Now we're still walking around the mall. Okay, this is like day one. We feel nothing of this. This would
Day
be
two.
our immune system starts kicking in. Now that is what we're going to feel. All right. So who could say that word at the bottom of the screen?
I
can't
see
see
it.
Dendritic cells.
All right. So what word?
Plasmacytoid dendritic cells or
So
something.
people just say the dendritic part, right? And kind of skip the other part. But plasma reminds you of what? What do we think when we hear plasma?
Really hot
Cell live.
lava fire stuff.
Same.
Where does this cell live?
In your blood.
In your blood. That's right. So our blood cells come into play now. We've activated our certain parts of our immune system, and the dendritic cells have come to save sort of the day. Not quite all of the day, right? They
They
come
just take some viruses and leave.
Well, they basically scan and go, you know what? You're right. Instead of one cell sending out, like the cytokines sending out the interferon, the dendritic cells are gonna just, pew, it's almost like a smoke alarm is gonna go off. So they are going to just spread all of these warning to everyone, right? You're gonna
The
say,
policeman chasing after a car thief.
that's right, but they don't know where. So the virus is still hiding. We don't know which cell is infected because they're in the Trojan horse, those soldiers, okay? So right now we've just kind of shut all the factories down and we just sending all the warnings to all the cells. And that's where our first part of our immune system is going.
I do have a question.
Yes.
So if we shut down all production in our cells, does the one with the virus continue production?
No, we've stopped,
Yeah.
right? We can't because will only, the cells are like, no, I'm not producing you because I have shut down. I've got the warning and I've shut everything down. Because the cell doesn't know if it's infected. All right. So it's going to shut everything down and it's kind of releasing everything. So the epithelial cells, or we'll just call them cells, they recognize that they could be infected. Okay. So they're going to stop production or slow down to slow the infection. All right. All right, guys, this is you guys. Who's ever been here?
what?
Who's ever looked like this before?
Me.
Not that bad.
A runny nose, a headache, a cough, a sore throat. Does this sound familiar?
Yeah,
I had that
definitely.
So is
had
this
that a few days ago.
Is this our virus doing this?
No, it's the response of your immune system.
It's your
You.
cell. It's your own immune system doing this to you. But why is it doing this?
to make sure you stay alive.
So it can,
Since it
like,
stopped all
has
of the
recovery.
Why do you have a runny nose?
She's
all
trying to
the mucus
To try to get the
virus
cells-
out.
mucus.
Yeah,
Trying to get the virus out.
we're using our mucus layer, mucus membrane here to get all of the virus, whatever it can find out, right? We're all also generally not hungry during this time. Does anybody know why you're not hungry?
Because you don't need the energy.
Acid cells.
It has to do with energy. Very good. So your body is going, we don't want to do anything else. We're not going to put energy to eating anything because what's the point? We're not producing and your cells are not using any energy, right? We've shut the factory down. So we're going to not be hungry and focus on the battle, right? Now we're in a battle. So this is our true immune system response. All right. What else happens? Can you see at the bottom of the page there? I don't know if you guys have it. There you go. The cytokine, there's another type of cytokine that happens because you start to get a fever. Why do you get a
You
fever?
try to burn up the virus
Ha
because the viruses don't like heat. They like the cold.
They gotta burn it off.
Okay. So the cytokine, can anybody read that word for me at the very bottom?
Pyrogen.
Okay. Where do
Pyrogen.
you hear the word pyro? What does that mean?
Pyrotechnics.
Fire.
Fire.
Fire. Yeah.
But
That's-
thankfully, we don't actually get lit on fire.
That's right. So how it does this is who's ever heard of the blood-brain barrier?
Me.
Me.
Okay, so essentially there's a barrier that prevents almost everything from going to your brain besides what your brain needs. So it's like, so you don't get viruses and you don't get bacteria and all that kind of stuff going to your brain. Well, there's a certain part of the blood-brain barrier that allows certain proteins or cytokines to go in it. And one of them is the pyrogens. So your immune system goes, send out the pyrogens, right? And it goes to your brain. And then your brain says, oh, we have a problem. We need to heat up our body to give our immune system a fighting chance against this virus. Okay. Now our cells, why aren't our cells damaged when our body is heated up?
But they're not making anything.
Our cells have something called heat shock proteins. Okay, so we can actually get pretty warm, and we're not going
Heat
to do.
resistant.
Yeah. So, but the
And,
virus,
like, your average is 98 degrees.
that's right. So you only need to go up a couple degrees, but this is generally why, like, you don't need to really take medicine unless your fever gets too high. You want your body to be warm. So how does it heat up your body? Does anyone know how your body heats up on its own?
You like
All
to
of
have
the blood in your body like pulls up in one area, I think.
You remember doing this?
It
Never
shakes
done that in my whole entire
together.
life.
So you get the shivers. Okay, so when you exercise,
Oh, if you keep on moving your muscles, then it'll get warmer.
yes, exactly. When you exercise, you're contracting your muscles and then you start sweating, right? Well, your body goes, I want to do that. So it contracts your muscles and it is going to be in the form of you shivering, like you're cold, but you're not cold, right? But your body is trying to contract your muscles to heat it up.
Why? Oh,
Okay, so then what else it does is it constricts your blood vessels. So think of like a cooler with an insulator. So when you constrict your blood vessels, it then insulates your core, which means heat is not being released anymore. So your skin feels cold. Okay, because it's keeping all the heat in and not letting any of it out. So the touch of your skin could be cold and you might feel cold, but and you're shivering like you're cold, but your muscles are just contracting to warm the core up. So that's why you have a fever. So a fever is actually a really, really good thing. Like my littlest Victor, when he got the flu, I think his temperature went to like 103, and we didn't have to give him any medication. He fought it off. He was fine. Mhm. So sometimes people take medication for symptoms to feel better, right? Let's see.
Don't. It'll make it worse.
Yeah. Miss Jen's not on today, is she? She could tell us all.
I am.
Oh, yes. Would you like
You're
to
doing perfectly.
Miss Jen?
Now, I will say, once you get up to 103, most people will treat to prevent fever, or will prevent seizures,
Right.
because you'll hear a lot of little kids will get seizures with fevers. But you also have to know that once the temperature is 103, you're pretty much not going to have the seizure, because it depends on the seizures caused by how quickly the fever pops up, like how fast it rises from a normal to a high temperature. And that can cause a different response in our body to create a seizure. So yeah, fever management, generally, if you're under 102, no reason to give medicines unless you're just miserable and can't manage yourself. Because otherwise the fevers help fighting your body. I mean, your immune system is helping
Your
it.
That's
Yeah,
right.
it's helped your body fight. And
Bless
that's
your-
why we also say, if you have a fever, don't wrap up. See this guy in this picture? I hate it. Because if you
why?
have a fever,
Yeah.
you should not have a hat on. You should not have a warm fuzzy blanket.
Mhm.
You should have on a thin layer, like a thin pajama layer,
Uh-huh.
and a thin sheet. And that's it. Because a blanket works like an insulator. So it's like a coffee cup, and it's going to hold your fever in. And you don't want your fever to get higher. Your fever will produce naturally by your body, which is great, but
Yep.
you don't want to artificially increase it by heating yourself while you have a fever. So that's why if you go to the hospital or the doctor and you have a fever, the first thing we tell you is don't wrap your baby in that big warm fuzzy blanket. Take off that big jacket. And everybody gets really upset because they don't like it, but it is what's best for your body.
Miss Tara,
Thank you, Dr. Jen, our resident nurse here.
what
Yeah.
if you're
Else?
My other thought was when you were talking about cytokines.
Yes. Here, let me see.
Now the cytokine, right? Cytokine storm is what you always heard with COVID.
Yeah.
And the cytokine storm can be extremely dangerous, and that is a life-threatening response. If those cytokines get kind of out of control, as you said, it kind of pushes pause on everything, right?
That's right.
And it targets everything to say, wait, let's stop. Let's not do things. Let's see what's going on. But it was what was actually killing most people with COVID, because some people will have an exaggerated cytokine response. Not everyone, and it did seem to run in families or have different type of connecting things that we were always trying to figure out. But the people that got in danger were the people who got a cytokine storm response, which usually occurred about 7 days after they were exposed to the virus. So it
Yep.
was really interesting. Or 7 days after they started symptoms of the virus, once their body recognized the virus was there.
Okay. So that's exactly what I have right here. So 3 days into
Oh, I'm sorry.
No, that's a great transition actually, because I have written down your immune system has a license to kill you.
I
So-
actually have
Does.
Yeah, so this is what
That
Ms.
is very
is talking about,
dangerous.
right? This is your immune system that is actually ramping up, your cytokines are ramping up. They're effectively killing your cells, right? They don't know where the virus is. So they just went, kill. Everybody go. This is also where you can get autoimmune disease, where
which I have.
You do? Okay. So this is where your body is thinking that something is wrong, right? And Miss Jen could probably elaborate on this. And then it's actually killing the cells and it's not supposed to.
Right. And that can be as simple from like, that's what your allergic, like allergic responses are, right? So if any of you have severe allergies and you carry your little EpiPens, or even seasonal allergies or asthma, things like that, that's the same type of response. It's where your body thinks something's deadly wrong and there's really nothing deadly wrong. And you're having a response that other people would not have because the cells in your body recognize it as bad, right?
Yep.
And in a similar way, it's like, as you describe it, we talk a lot about, like cancer and chemotherapy to treat cancer. Most of us are all familiar with the idea that cancer are mutated cells, and chemo is supposed to kind of go in and try to target those cells. But we also know when someone is taking chemotherapy, what happens? They get very sick, right? And the reason is it's an exaggeration kill response, and it goes in and it kills blindly. And if your immune system, chemo can't be as good as our regular immune systems, which recognize the specific cell to attack, right? And if our immune system isn't up to par and it doesn't recognize the specific cells and it just starts killing at will, then it's the same idea. You get very sick. You get fevers and chills and, responses like rashes and nausea and, can die essentially from your own immune system. With COVID, that cytokine response caused increased mucus. So you're talking about all that increased mucus in your lungs. And what actually happened is people suffocated. You had such high levels of mucus within the lungs, and we don't have a way to go into those alveoli and remove mucus from each individual alveoli. Like when you're talking about how many square yards of skin you have surface within the lungs themselves, we can't go in there and scrape that out, right? You can go in and get larger areas with bronchiectomies. You can go in and do like different things, but you can't get those little tiny surfaces. And that's where the oxygen is actually transferred in your body. And if that's all plugged up with mucus, your body can't get oxygen, right? And that was the problem with COVID, was your body just would produce all this stuff trying to help him fight, and it clogged up your lungs and you couldn't breathe.
Any questions?
Yeah.
Okay, go for it, Mouse.
What if your temperature is 110 or 112?
Well, that's incompatible with life, so you would not have that temperature.
But there's this guy that survived a temperature of 117.
He would
in
have had to
ice.
have other in ice, right? Like if you have other modifications going on, he didn't survive that temperature. He was modifying that temperature, and he could get that temperature at one spot, but he's modifying it in other ways. But no, your temperature is not going to be 112.
Yeah, that would start hurting your brain.
Right. Those people are unconscious, not
Yeah.
speaking, not talking, and your brain is swollen, and they're not going to live.
How's your brain swollen? That's just creepy.
It is, isn't it?
It swells up and starts hurting itself.
It swells and fluid gets in there. So fluid gets in between like that blood-brain barrier, those casings and sheath of the brain, as well as like the tissue itself, right? If you go and if you strain your ankle or something, right? Or if you go and you work out and lift weights, then your muscles, like you guys probably aren't big enough, but a lot of men, my husband is very annoying. He goes and he works out and he does like one thing, and the next day, like his bicep muscles, you're like, how do you get like swollen muscles by like one day of working out, right? And it's because of an inflammation response where your muscles like swelling up physically by, working and being inflamed. Well, your brain does kind of the same thing if it's triggered by different things, and fever can be one of them. That's why you'd get a seizure even, right? Like but it can swell and cause some problems
Oh.
because it's in a closed space, right? Like your skull is there and it doesn't, your
Usually
arm, it's fine for it to swell.
they have to drain,
Brain,
right?
not so much.
They have to drain.
Hmm?
If it swells, they have to drain the blood, I think, from your brain.
Yeah, yeah. So if you're starting having problems with that, there's a lot of different ways. If there's swelling within just some of the sheaths, you can actually put a needle in the lower back and drain some of the fluid out, right? And you can do that therapeutically. We do it to test the fluid in the lining around the brain. But you can also, we measure the pressure when we do that procedure. So I'll put a needle in someone's back and go into their spinal fluid, and you measure the pressure as it comes out, like a dangerous pressure, like I've put them in there sometimes, and like they hit the wall behind me, like it's shooting out, and that's a bad sign. It should just kind of drip out, like in little tiny dribbles. And if it's high, draining some of that off can actually help and help relieve some of that pressure, but you can't do it for long because we need that fluid to some degree, right?
So it hits the wall behind you?
Well, I mean, yeah, like it's just a lot of pressure, right? Like a
Oh,
water
wow.
spigot, right? If you turn it on real fast and it's got a lot of pressure, it shoots out.
I
right?
would never be able to stand that.
It's cool. You'd love it.
It's cool.
You got to stand out. You got to stand to the side. You learn never to stand directly behind them when you do this. And you wear some protective gowns if you really suspect things like that.
So the gist is your
But
body
the other
trying to
option
kill
is
you.
if the brain is swelling, you can, sometimes they go and they actually cut windows into the skull, right? And they'll, drill holes or things like that to just help relieve that pressure, right? Because the problem is your skull is a closed space, right? But we've gotten way away from our viruses. So go ahead and get back to your viruses. Sorry.
About brain bleeding. Woohoo.
Woohoo.
All right, let's see. If that is cool to you, you should definitely become a doctor or a nurse. All right, so the next thing that happens in our lovely scenario here, our immune system is kicking in. So before we bring in the big guns, okay, quote unquote, the big killer cells, right? They're going to need a way to find the virus. Okay, so a really cool thing happens in your cells. Can anybody read the word on the left side there? Major
Histocompatibility.
Okay, so we don't want to say that continually over and over again. We're going to use the acronym MHC. Okay, and it's a type of molecule your cell makes. And it basically, there's two types, the first class and the second class. The first class of MHC gives you, it's like a little window into your cell. So when the big guns of your immune system come out, they can kind of go by the cell, look inside of the cell and see what's going on, right? So it can find the virus. Like, does this cell have a virus? Nope. On to the next one, okay? The second type of molecule your cells will start to make kind of look like hot dogs, okay? And it's almost like a tray that they go, okay, we have found a virus, we have destroyed it, and here are pieces of it, and this is what it looks like. So it's presenting the antigen is what that's called. So you guys will want to write this down. It's MHC class 1 makes it visible, okay? The cell inside visible. And then MHC class 2 kind of presents the antigen. Like, this is what you're looking for, people. This is part of your virus. It's not really good. Now, this is pretty cool because every cell with a nucleus has an MHC class 1, like a little window, and it's only unique to you, sort of like a fingerprint. Like, I don't even think identical twins would have the same type of MHC class molecule. This becomes a problem when you have like organ transplants. And you ever heard of someone having an organ transplant and their body rejecting it?
Yeah.
Yeah.
That's what it was. That's why you need a specific type of blood transplant too.
So it has something to do with this. So your body might reject it because you have this unique class of molecules in your cells. And your cells, if they put a little window into the new organ and go, wait a second, this looks different. This is a totally different MHC class molecule. Let's destroy it, right? And so
They'll start maturing that
right. So
that
that's
new
where
organ.
you have to take medication, and I'm sure Miss Jen can elaborate, but you have to take medication to suppress that immune response. Your immune system has to go way low so it doesn't kill the new organ, right? So usually it would be detrimental if someone was in the hospital who had an organ transplant or something going on, and we've chemically said, we're going to lower your immune system, and then they got a virus. That would not be good, right, guys? Because their immune system would be low. So these are really cool, the MHC class molecules inside your cells, and they make these. It's pretty cool. Now, the MHC class 2, the one that kind of presents the antigen, is only in the dendritic cells and the okay, so Miss Jen, do you call it the macrophage or phage or phage?
Macrophage. I say
French had a little French to it.
Phage. She might have left. Okay.
No, I had it muted and I couldn't find the place to unmute it. It's macrophage. That's why I was like, yep, I've always said bacteriophage, but I'm sure it's supposed to be phage because everything else is.
Okay, so
macrophage.
this is sort of a representation of one of the cells, right? So we have on one side these little, here is the virus, everybody, and it presents the virus or the antigen, right? And then on the other side, it could go, oh, here's a little window into seeing what the virus inside will look like. All right. Now, this will help, if you notice in this picture, something called a helper T and a killer cell. And that's where our story becomes even cooler. All right. So now our immune response has begun. We call this the adaptive immune system. Okay. So now this is the big ammo jamma.
No.
We have initiated what, guys?
The killer T cell.
Killer T cells, right? So we've initiated them, and then something called the natural killer cells, and we'll talk about those in a second. So these killer T cells.
Wait, don't killer T cells just like implode whenever they catch a virus or something?
Okay, so they don't want to necessarily implode them because the virus would just go everywhere, right? So they make a little area where the virus can be encapsulated in like the carcass of the cell, okay? And then when that happens, that's where our macrophage, right? Our eaters go, oh, I'll come gobble you up. Okay, because we don't want to just release the virus. They're going to kill the cell and then strategically encase the virus in something where it can't go out and infect anything else. And so it's just kind of floating around in this, like the carcass of the dead cell, right? And then the macrophage, which we love the macrophage, it keeps eating things and destroying things for us. It's our garbage men, right? It's cleaning up everything. And this also releases tons of cytotoxins, okay? And that's how it's going to effectively kill the cell and the virus inside. So sometimes, like if these are deep within your lungs, this is like sometimes about 10 days after. This is major killer cells. Miss Jen, anything to add about killer T cells? Oh, she's on
Not
mute.
really. I will say if if you haven't seen, what was that show, kids? The
Cells at work.
Cells at work. Yeah.
Cells at Work.
Cells at work.
It's amazing for all of these cells and learning which cells does what and their jobs in a fun storyline way. I love
Okay.
it.
Is
So
that
if
on
any of y'all haven't seen that one, that's how my kids learned all these like killer shit, like keeping the, because it was hard even for me, like when I was in college learning this, trying to keep all these different cell types straight.
Yeah.
And the storyline works great. I have a friend who teaches at a master's level, and she's like, oh, when I told her that we were watching that, she was like, oh, I now tell all of my people to watch that because it's a hard concept to keep straight.
Is that YouTube or is that like a Netflix thing?
Netflix.
Is it Netflix?
Netflix.
Okay.
It was
Yeah.
Netflix. I think at one point it was removed and you could still find it on YouTube. But
Okay.
then she told me that it came back to Netflix. Like one of her students was having trouble finding it and they let her know
It's
it had come
only
back.
on,
So I think it goes off and on Netflix.
it's just not on the kids account because it has a lot of blood in it because it's
It's blood.
Right.
But
It's
Yeah.
like
it's
it doesn't
anime.
have
It's
Yeah.
bad
anime,
language or
so-
things like that, but it does have a lot of blood.
Yeah.
because it's inside of a body.
We'll have to
And
watch
they're
it.
fighting a lot of things, right?
Yeah.
It's a fun show. And it does teach you very well there, especially once you know kind of the basics of their job description of each cell. You
Mhm.
see it. And the killer T cells are in there. They're fun.
Yep.
And they come in as big guns, right, guys?
They even
That's
have
right.
a cancer.
Yeah,
Big-
each episode's like a different thing. Like there's cancer.
There's a
I think
virus.
there's,
and
yeah,
Actually,
there's influenza
influenza.
one too.
Yeah.
Oh, cool.
Or a cut, like if your body gets a cut, what happens?
Nice.
It's
Okay,
very
we'll have to watch it.
Mhm.
It would go great with this class for sure. So
It
these
would. It would.
natural killer cells are looking for, now these things can actually be quite dangerous, right, Miss Jen? I mean, they are constantly, they're arriving on our lovely battlefield, right? Trying to destroy everything about 2 to 3 days after the infection. And they check to see if this cell is stressed or showing that MHC class and see if there's actually those windows there that they can see through. And they're going, is there something wrong? So if they see something wrong, then they'll go ahead and kill the cell. Okay, so that is our natural killer cell.
But they order the cell to kill itself.
Yeah. Thank you. Okay, so let's give a rundown of how our viral infection is eradicated. All right, so we got millions of our cells dying. What's next, guys?
Infection.
What happens? What type of immune system kicks in? What's the first type?
Cells dying, dead bodies everywhere, fever going higher.
We call it our innate immune system kicks in, all right? To stop saying
It's
stop,
all downhill from here.
right? We're stopping the production of our protein, our cells, right? Making proteins. Then what happens?
And then it wake up, all the systems wake up and they try to fight on the virus.
All right. So our temperature increases, right? But now we're actually feeling sick, right? Our immune system generally starts to wake up. Our big immune system will start to wake up like, a couple days after. This is why usually you don't have any symptoms till your immune system kicks in, right? So all the systems wake up producing, now you're snotting everywhere, right? You're coughing, you're trying to remove the virus. This is where, this is the cytokine release is making you feel even worse, right? All right, so then your natural killer, now the big guns come in. We have our natural killer cells, our T cells, right? So they are now literally killing all the infected cells. So now we've shut down production. Now we can actually start finding the infected cells and starting to kill them. And then our lovely friends, the macrophages or phage, our lovely little garbage
Macrophage.
macrophage, our garbage men, are cleaning up all the mess, right? All the dead cells, all the dead viruses, they're eating them all up, right? We have some of our dendritic cells. They're kind of looking around the battlefield going, all right, we're picking up some virus pieces and we're going to start displaying them, showing them around all the cells going, this is what it looks like. Find this, right? And that's when our killer T's like, gotcha. I'm going to start activating our antibodies. And we'll talk about B cells, vaccines, immunity next time. Because we got.
I don't think B cells attack viruses because they spray antibodies.
That's right. They do antibodies. Yeah. And our final battle is won, right?
Victory.
Or not.
Or not. That's right. So here's a little diagram, but that is our story of now. I think next time we'll probably get into maybe memory on how to remember to what viruses came into our body, how to kind of regulate all that. Let's see, can stop here, get out of that. All right, so that was our story for today. Was it a lovely bedtime story?
Yeah.
Yeah.
No. No. Not in the slightest.
Is everybody ready to be infected with a virus?
No.
Yeah.
Not really.
I have a basketball tournament in 2 days. No.
Yes,
Can I
I'm
just
so
can I
excited.
get infected and then take a little camera in there and record it all?
No, why should we do the next? Oh yeah, I love.
All right, so are we ready for our Kahoot? Did everybody take notes?
Sorry for a Kahoot.
Does anybody have any questions before we do our Kahoot?
No.
No, we do the
I was
Kahoot.
wondering what a Kahoot
Does a
is.
virus have to do with if I think about breaking my leg now hurts?
Okay, I see what you're saying. That is definitely
That's how Grace felt.
that's a Miss Jen question. She had to take a call real quick. But you're talking about
Ready to go.
body aches, why your body aches and stuff when you're sick. Okay. Well, we'll ask Miss Jen when she comes back on.
Yeah.
Yeah. Okay.
Okay.
Oh no.
I'm starting. Okay.
Starting.
All right, here we go.
Mm-hmm.
Ready?
I need my notes. My notes.
Oh. Okay. Okay, let's see again. I would choose blue. Oh, it's good. Oh, it's
Oh
green.
my god. I can't answer fast enough.
1 point behind impersonator. Bacterial killed?
Bro, look how fast those
Everyone. That was funny to watch.
Somebody wrote that down.
Yeah.
Bacteria.
That one is good.
I wrote basically everything there was to write down. I filled up 5 pages.
Yeah.
Yay. Emma,
What?
it's 8. I can't believe it. Stop giving me the
Going fourth.
Yes. Haha.
Thank you. It's true. Let's see the virus.
No.
Oh, I will choose blue. Oh, yay.
Fourth place. We're fifth. No, fourth.
Our prize. We go. Let's see.
Oh, yes. We're third. Oh man, I can't believe.
Red. Okay.
Wait. Miss Tara. It said
I'm
the virus
3
replicate very
points
quickly
behind
in
the
the
nickname, and
in a
I'm
cell.
7th.
One question, and that got me to
I'm aiming for the podium.
rubber snot on everything.
Maybe.
Not each hands.
What?
Each hands.
I'm
What's
guessing
eating.
each hands.
Let's see what it
Hands
is.
before eating.
Let's see.
Sorry, guys. Autocorrect. It's supposed
It's
to be
supposed to be
Miss
wash
your
hands.
hands.
Miss
Okay,
Tara?
because we're like each hands.
Somebody actually picked stop breathing.
On
Miss
yellow.
Tara?
Yeah.
I'm in 4th place. I'm in 4th place. How?
Let's see what it is. On blue.
Yeah, blue.
Never start.
We're down here.
Miss Tara?
Yes.
Words and bombs.
So I saw that one of the questions was
Don't
like
care,
a virus takes a short amount of time
You're
to replicate.
We'll have to talk about I got this one in my ear, Levi.
Okay.
And then
Like
everyone
it said that a virus takes a
we'll
long
hear
time
your
to
question in a
replicate.
minute.
Some viruses take a couple of weeks.
Oh, a couple weeks. Is that what you said?
I don't breathe there.
One bucket of air.
One bucket.
I
One
could have
one
sworn.
Home Depot sized bucket.
Okay. Next.
Live their best life.
Relax and be happy, guys. Relax and be
Oh, who chose live their best life?
On red.
Long
Ravioli.
Sacks.
Ravioli.
I hit lungs.
It's on red again.
Bro, lungs.
I hit. Why did I hit lung sex?
Let's see. On the body.
It's those scary cells.
Scared.
Yay, 5th
It's
place.
I'm so bad at this.
Emma.
What?
This is on yellow.
Never. My cells.
My
like
cells are like,
Chuck
shut
I am horrible at it.
Norris. What?
Lazy protein.
Lazy proteins.
None.
No, bro, there none. My cells are like Chuck Norris.
Guys, I think. Beautiful
A
day.
beautiful
I'm choosing the
day.
most specific answer.
A beautiful day.
Yeah.
I know. It can create a beautiful
Yellow.
day.
It was a
All
beautiful
of
day.
them.
No, it wasn't.
We need to get all the way to 29.
Die.
Okay, next one.
They surrender and
Die.
die.
They make you want to dance.
Why not?
Yes.
Bro, they just surrender and die.
Did you get it right?
I did.
Run away.
Bro, think
crazy.
about life.
Go crazy.
Think about what life is all about.
Go
You need to
crazy, yeah.
dwell on the thought of
Yeah.
life.
Yeah, let's go crazy. Yeah.
That's runaway virus. Okay, let's see.
Standing virus
Mean
cells.
cells. It's the mean blood cells.
Yeah.
I guess you're wrong again. We need to get all the way to 29.
Furnace proteins, fire cells, stove cells.
Fire thingy. Ah.
Whoa, that's good. Quiz time.
Garbage truck proteins.
I think this is too easy for you guys.
No, it's not.
Babies.
I mean, like, look at the answers.
Hey, I can't believe I got it right just at a wild guess.
Okay. I'll see baby cells. Let's see. Oh my god. Class.
Yeah.
None of these are right.
It
was
was
Oh my god, class 1.
Bro, none of these are right.
It's class 1.
Yeah, it's not class 2.
Oh,
I just-
sorry.
I'm always 500 points behind Emma. That doesn't make any sense.
let's see, I can guess the
You
shit.
guys are too smart.
I chose
Friends.
It's
but
just sad.
Happiness. Happiness.
where?
Oh, it was stress.
I honestly was so
Where
confused for a
on
second.
Yeah.
Sadness.
2 hours. Triangle.
Oh no! I
No way.
2 hours.
No, you clicked
Bro, 2 hours? We don't even know it's there until 2 or 3 days.
one.
Oh.
I mean, like, feel free to look at the
That
picture.
one. But number 2?
Mhm.
There's only 1 and 2. 4 and 10 don't exist.
Well, number 10. I was so
Kill you. Kill
It
you.
has a license to drive. Bro,
To buy cigarettes?
Kill you.
Who chose to buy cigarettes?
Bonus. How many cells are you? Oh no.
Dude, there are 2. There are exactly
No,
2
Levi, it's
cells
40
in your
trillion. Because
body.
remember, it's a song.
There's no way to tell if there's
2. Let's see
2 cells.
18,856 points.
Your body is made of 2 cells, the upper cell and the lower cell.
Purposely lost.
Oh. Oh, look, I won.
Impersonator.
Grace, you got that was Levi. Grace,
I
you
got
next year, right?
18,856 points.
Hey, Emma,
can't
Emma, did you
see
say
it.
your
Who
name
won
for the
that
podium next
round?
time?
Who won it?
Okay. Emma,
What'd you say,
Oh,
Lola?
Emma,
oh,
did you
I
get
won
number
it.
2?
I'm sorry. Maybe I should stop.
However you pronounce it.
All right, who got second place?
Yeah.
Who was second place?
Me.
Grace.
Good job, Grace. Third place.
We were 3rd.
All right, fourth place.
Me.
And fifth place.
Me.
Good job, guys.
Wait, when you get fourth for the 5th place, does it still tell you to aim for the podium?
Yeah.
No, it actually, mine didn't say that. It actually for once said good job.
Oh, I think anything below 5th.
What?
it tells
What?
you
What?
Aim for the podium next time.
First place?
I got 5th place.
Oh,
Did it tell you to aim for the podium?
No, it didn't say anything. I think it was just so majorly disappointed in me that it just didn't want to say anything.
Bro, what?
Oh, no, you got to stop. Remember, you got to, Miles can't do that because people can't see
Why
it.
don't you take off where everyone else can
Oh.
share?
Remember. All
Like,
right.
what-
Good
how is he sharing
class,
a
guys.
whiteboard?